I am Beh Haoyun, but you just call me Gary because it's easier to remember. I work as a research engineer at ROS Industrial Consortium Asia Pacific, and I specialize in computer vision and just ROS in general. Yeah, I typically work in the area where I enable ROS programs with computer vision features, especially now when the computer vision field is so bustling. Yeah. Then, as a quick context for these slides, I am the lead developer for Easy Perception deployment, and later on, once we start, I will go into further detail on what this software does exactly. Yeah. Daryl, shall I continue on with the presentation? Okay, then I shall start. So again, thank you for taking the time to be here. In I know that it's a Thursday evening, so I won't take too much of your time. Therefore, in the next 15 or so minutes, I'd like to share with you a program that I've written, which if you are a roboticist, aka if you are looking to enable your robotics program to have computer vision capabilities, this is the program for you because it is built on top of ROS2. Now, for those that are unfamiliar with ROS in this group, very briefly, ROS is a middleware platform in which you can design modular units for components such as sensors, robotic agents, robotic manipulator, and then to just fuse them all together into a feasible, practical solution. Because it's often the case where you don't just have one robotic arm that works with itself to as an industrial solution. You have multiple sensors hooked up all together in a complex mesh to provide something practical to industries. And one of this package which I like to introduce into this ecosystem is EPD, Easy Perception Deployment. Okay, so next slide. In one sentence here, EPD is a ROS2 package that accelerates the training and deployment of custom trained computer vision model for industries. I like to emphasize on three keywords here. One is training, the other is deployment, and the third is industries. And I'll elaborate more on why I emphasize on these keywords. These keywords all decide what are the core design principles I've chosen to guide the growth of EPD's architecture and how it makes use of specific dependencies in order to make it, in order to adhere to those keywords. First of all, let's talk about industries. You want to have software without thinking too much about the legal repercussions, such as licensing. It is often a hassle when you have to work out the details for proprietary software. And therefore, APD distinguishes itself by being permissively licensed under the Apache 2.0 license and in general just being open source. You can use, you can access it now, this package, and then build commercial products off of it without having to pay the the typical kind of royalty or the proprietary license that more closed off softwares have. The other is in terms of the training. That's the first keyword. Here in the second statement, in terms of training, it is using the concept of transfer learning. And by using transfer learning, what it does is it takes pre-trained models and then train on top of it. This is in contrast to creating models from scratch and then training them from scratch. If you train this kind of deep learning model from scratch, I can assure you, you take the most powerful GPU you have right at the moment in this world, it still takes about 1 month to train this model from scratch and then deploy it. But if you use transfer learning, we start off from already a fixed checkpoint, and this pre-trained model already has learned how to detect generic object features, and we train on top of it. So from 1 month, we reduce it to 1.5 hours. Yeah. That also relates to deployment. And also in terms of deployment, it has a GUI, which I will show you very, very shortly. And when we design EPD, we have in mind our target audience, which is users with no programming background. Yeah, especially when you are an engineer, you are a system integrator, you want to get the system up and running as soon as possible. This program is, you want to use this program. And of course, in order to keep up to date with the state-of-the-art models in deep learning, computer vision, that field is extremely fluid. Every single year, there's new state-of-the-art deep learning models that's beating each other. And therefore, in order to stay on top of it, in order to prevent being locked within a machine learning library, we have specifically selected to depend on the open standard for ONNX, yeah, which most machine learning libraries like TensorFlow, PyTorch, MXNet, gluon-CV, Chain-CV, the list goes on, which they all export to ONNX. Yeah. Now, I would like to elaborate specifically on the keyword of training here. And we shall keep things simple. You can think of EPD as a very simple maths function. A maths function takes in inputs and then processes it like a function and outputs something. So for training, it takes in a folder full of training images and then a .text file to map what are the classes in those images that you have labeled. It passes it to EPD, and it trains it, and what it ultimately generates is this .onnx file, this model that you can use and deploy. And this is how it looks like in terms of the GUI. The main window is on the left. I'm clicking on the train button, and the train window is on the right. Yeah, and it uses a very simple color code. And if you see that everything is green, everything is good to go, and you are able to train it. I'll now focus on deploy, the second keyword. Here, also the same. As a max function, there's inputs and outputs. The inputs is you take the model that you just trained, and you take the label list that you just used. And from there, EPD processes it and then deploys it as a ROS2 package. And the significance of doing so is that now the data generated by this model that you deploy is now accessible to every other ROS2 package that is supposed to instantiate different sensors, different robotic manipulators that are out there in the ROS2 ecosystem. And I strongly encourage you to just do a quick Google search, ROS2 packages, and what are the different companies that offer up their software drivers in the ROS2 ecosystem. Yeah. And similarly, this is a GUI. I click on the deploy button, and this is the deploy window. Yeah, and you can toggle between CPU and GPU. Now, for what exactly this model does, I keep on talking about training the model, I keep on talking about deploying the model, but what is the model actually doing? Well, for deep learning models that we use in EPD, our main concern is this. We want to take in a 2D image, and we want to know what is the object in the frame, and then where is the object, which are all covered under three main use cases. One is object classification. You can visualize this as 2D images with bounding boxes that show where the image is, and then object localization / tracking, where it tells you the Euclidean position of where these objects are relative to the camera frame. Yeah, and those information are extremely integral to very common industrial application, such as picking system. You need to know where the object is. And if you want to know which objects to pick, that's where object classification comes into play. Yeah. And other than the different use cases that this object, this EPD model caters to, the models also vary in terms of how precise it can be. You don't have just one size fits all kind of model in computer vision. There is a clear distinction between general AI and then specialized AI. General AI is what you think about like Deep Blue. It's just meant to solve uh, general tasks and it's supposed to, one day like take over the world, that kind of thing. But for specialized AI, is trains for that specific task. And for now, in abundance, there is all this specialized AI for computer vision. And since there are so many, and it's supposed to suit so many different use cases, at least for APD, this is what we try and do to cover as many use cases as possible. We offer 3 different precision levels, and it's often a trade-off between speed and accuracy. On the one hand, you have models that is extremely fast, but is not as accurate as you want it. It's not super accurate. And then on the other hand, you have models that are extremely accurate, but they are slow and clunky. Yeah. So it depends on what use case you need. Do you need speed? Do you need accuracy? And the flexibility is there. You can select it. And I'm going to show you how you can select it very shortly as well. Yeah, sorry for the formatting issue. So for precision level 1, we are using SqueezeNet .onnx. These are a different variety of pre-trained models that already come prepared in the EPD, even without any training. For the custom messages, I know it's a bit of a mess. So later on, I'll direct you to the GitHub link in which you can view the proper documentation, which goes through this in better detail. Yeah. And then to just delve deeper into the use case, and this is what you will see in the GUI later on when I show you the video. The classification it can be done for all the precision models. For counting is relegated to 2 and 3, color matching 2 and 3. Localization is 3, and localization tracking is P3. Now you might be confused as to what this like P1, P2, P3 means. Well, from precision 1 to precision level 3, precision level 1 is the fastest but not accurate. Not as accurate as the rest. And its output is expected to be you taking a 2D image and all it outputs is the string, the object name that it detects the whole image to be. But for precision level 2 is generating bounding boxes that follow the specific area of a 2D image, and then shows that this bounding box is representative of the object that is being detected. And then we delve even deeper into the bounding box with precision level 3 by actually displaying the segmentation mask. And later on, I'm going to show visual examples of how all this use case, right, what they output exactly. Yeah. As a quick disclaimer here, the localization, we combine it with measurements because it it typically goes hand in hand. Yeah, and the same goes with the object tracking. So this is for classification. Precision level 1, if I feed it the image of the oxygen mask, then it will just give me a string saying that, hey, I detected oxygen mask. But for precision level 2, that's what you'll see for typical academic releases of object detection using deep learning models. Very typically like YOLO, if you heard of it. And then for precision level 3, the bounding box is there, but there's inside it, you have the specific mask that goes around the object itself, outlining it specifically. Yeah. And then for counting, that's where we introduce a subtractive model approach. You have all these pre-trained models and you don't really want to train your own custom models yet. And therefore, in order to deal with all this noise, right, you see on the left-hand side, there's person, there's bench, there's car. If for my use case, I just want to concentrate on the person. And therefore, I have this use case available to me to just filter out all these unwanted objects in the frame and concentrate on what I want. Yeah. And then for color matching, it is very similar to the filter you just saw for counting, but instead of filtering it by the class name, you're filtering it by the color. Yeah. And this one is very, very useful in terms of, let's say you want to sort whether an apple is rotten or different fruits are or different grades for like certain like I'm not sure how to say fruit industries, industries that produce fruits. Yeah, plantations. Yes. And finally, this is a localization, measurement, and tracking, where it's relegated to precision level 3 models, and therefore you see the specific mask that goes around, like let's say this kind of shampoo bottle that you very much see quite often in a lot of industrial use cases. Yeah, and it outputs the calculated centroid, it outputs the estimated length, breadth, and height for the measurement. Yeah, and then for the tracking part, the image is not showing. That one, yeah, apologies for this format error. I would have to redirect you to the documentation to see more of this. Yeah, sorry. Oh, okay. It's here. I just didn't click. Didn't know there was animation. But yeah, in terms of tracking, right, you see that there's a unique identifier at the top here for each bottle. Yeah, and it will only assign unique IDs to each new object when it leaves the frame. Yeah, as long as it remains in the frame, despite major occlusion, it will still be able to track the object. Yeah. And I'm nearing the end of my presentation here. I'll just be showing a very quick demo that we have just done in terms of how we go from the general use case and down to the very specific use case where it is now applied in industrial in an industrial project. So here you see the computer, you see that this black box that I'll be zooming into, and then behind it there was the robotic cell. In this black box, you have the lighting system, you have a camera. For this case, I'm using an affordable $200 real cents D415. And then I'll jump into the actual GUI here. I click on the desktop shortcut, it pops out the GUI, and I'm just going to deploy straight away with the pre-trained models that you don't need to do anything to get. I'm going to click on precision level 3 model, which is a mass RCNN, get the label list that uses the standard COCO label class list. These are all the various use cases that is available. But for this demo, I'll just choose localization. And I'll choose to deploy in GPU. and then I run it. For generic objects like, my arm is good. My cell phone is also good. But here's where I need to train, because let's say for this specific custom object, it either doesn't detect it or it detects it wrong. This is not a kite. It is a sachet, like an instant drink packet. So if I want to train on this specifically, I need to collect all these photos of this specific object, and I need to classify it and annotate, label it to classify how to differentiate what position it is in. Yeah, I label it, I choose it, and I train it, and therefore I generated that ONNX file. Now I go to deploy. I select the custom trained model, and then I run it. And therefore now you see that it is detecting it the whole time, and is able to differentiate when it's pointing down and when it's pointing up. That's how accurate the model is. And now I'm going to show you how I'm translating this object localization results into a feasible real-time picking system on a conveyor. Yeah, and this one is how it picks it, and it takes into account its orientation. That's how precise the model can be trained to be. And just to make a point here, I'm just going to show, I just want you to see how every single sachet, even though they came in all different angles and whatnot, it all comes out at the same angle. Yeah. And that's it for the demo. This is my second last slide. If you would like to get started on using this EPD, it is freely available to the public right now. And as I said, this is open source, permissively licensed. You want to deploy in your own commercial product and earn money from it, go ahead. You can just scan the QR code. I'll just give you a quick 5 seconds to click on to just scan. Yeah. Yeah. So I also like to point out that this easy perception deployment is available on the official ROS industrial repository.
Okay, cool. Does anyone have any question for Gary, or any comments, or share anything?
Yep. Any questions?
I got one. So first of all, very impressive, very cool. I have like a slight background in the the TensorFlow stuff and the image recognition, but not so much in the actual application. So it was very interesting to see how fast you actually went from having the model. Now my question would be, I know there's like so many details in like what you put into the model, how big the image is, how the actual output format is. Is there, besides the few pre-trained models that you've already shown, can I just plug something random from the internet basically and put it in there and use it in this pipeline? Or is there something specific to each model where you have to, put in the input format,
Currently for the models that is allowed to run using EPD, right, it's still limited. However, if you do have your own custom model, feel free to post it as an issue, and then that's how I would, that's how we can work towards adding more parser functions, and then therefore EPD therefore knows how to instantiate that model and then get the right data from it, yeah, and then represent it in a visual or a more actionable format. Yeah. So
because I specifically remember when you mentioned YOLO. They now have what, version 3, version 4 is out, I think. Version 3, I'm not too sure. Just remember.
It is currently at version 5, and
5 already.
I believe it's by Ultralytics. Yeah.
Just remember, it's always a pain to get those running for the first time.
Yeah. Unfortunately for EPD now, we do not support YOLO because of how YOLO depends on very fixed image sizes. Yeah, And if you were to take in an input image like of any size, it has to skew it down to that specific input size in order to fit it into its fully connected network layer. Yeah, that is not the case for MASA CNN, and that's why we picked it for APD. The images can change or here and there, but it is meant to cater to a range of sizes. Yeah.
Right. Thanks. Very, very cool.
Okay. Thank you for the question. Any other question?
Okay, if there's no question, maybe we can go straight to Marco. Maybe at the end of Marco, then we can have a discussion.
Okay,
but at the end of it, we should also, because we should also try to get to know each other at the end of it. So, yeah, sorry, Gary, you wanted to say something? This one?
Yeah, so just to wrap things up, if
A-star.
you have got any other question, you can just email me there, or you can just check me out on GitHub. My username is Cardboard Code. Yeah, I'm also part of the ROS Industrial group of owners. Yeah, thank you.
Yeah, thanks, Gary. Okay, next we have Marco. So I don't know if any one of you have been to FOSS Asia. Probably you would have seen Marco before. What I didn't know was that Marco was also working on ROS. And maybe Marco can give us a little bit of background behind your company. And I thought it's a very interesting story that there's a team that is actually working in Singapore. I don't know how much you can share, whether it is confidential stuff or not.
Yeah, no, I'll share. Just let me start with the presentation.
Okay.
Yeah, this one works.
I did see Mario online, so probably he's occupied.
Should be able to see my slides now.
It's good.
All right. So yeah, my name is Marco. Some of you guys might know me from FOSS Asia. I've been always very passionate about open source. So I've been involved in FOSS Asia since I came to Singapore around 5 years ago. Also, I was actually part of A-Star at that time. Also been involved in many open source projects. Some of you also might have seen me around the hackerspace. So if you hung out there, I'm also a member. And yeah, around 1.5 years ago, I joined Open Robotics, and I joined the Singapore team. So there's the core team in Open Robotics is in California, but they came down and started a Singapore team. And mainly what we work here in Singapore is robotics middleware framework. So I'm going to talk mostly today. I'm going to talk about this. My specific work is related to the releases. So I work with the build farm. I work in releasing the packages for Ubuntu Debian packages, and we're also working on RPM packages for Red Hat distros of the robotics middleware framework. And I'm also doing some other work on the SD format, which is the format that we use for simulation environments and robotics models and all that. And it's the one you use with Gazebo and other simulation tools. So yeah, let's go into it. A little bit about Open Robotics. Open Robotics, we always like to go through this motto. We create open software and hardware platforms for robotics, and we use those platforms to solve important problems and help others do the same, right? And as I said, Open Robotics main team is in California, and that's where it all started. But it's also a bit spread out around the world. The second hub, it's here in Singapore. And we have a bunch of people spread out in North America. There's 3 guys in Spain, and we also have Geoffrey that is working with us from Japan with the Singapore team. For those of you that are not familiar with Open Robotics, we're mostly popular for steering two main projects. One is ROS, which is it's now in the second version, ROS 2. And the second one is Gazebo, which is also being rewritten into Ignition, which is it's in the end it's also can be used as a simulation tool, but it's decoupled and in a way that you have a bunch of libraries, and each of these libraries can be used independently. So you can use the Ignition math, and you can just use it for mathematics stuff, right? And then we have the software that is what keeps most part of the Singapore team busy, which is called OpenRMF. And it's what I'm here to present today. All right. So OpenRMF is tied to solve problems in multi-robots systems. So let's see what's happening there. So since robotics is a very rapidly evolving field, delivery it's very common, and there's new applications that are emerging, new companies, and facilities and infrastructures, they have to quickly adapt to this, right? So some of these processes of automation, they would require more than 1 or 2 robots to interact with each other. And this interaction of each subtask might require different robots for different vendors, right? So you might have one vendor that is providing the best robot to do one part of the task, and then some other vendors will provide other robots to provide the other part of the task, right? Or you might need them to interact with each other in a certain way. So it's very important to try to enable multi-vendor integration to create an open ecosystem where you don't get vendor locking when you want to run your robots in a certain infrastructure, right? However, there's a lot of challenges that come with this, right? So you get the first challenge that you get is the lack of interoperability. So the main problem that you have is that vendor A has a certain way of the robots talking to each other, and vendor B has a certain way that the robots talk to each other. So in the end, they don't talk between vendors, different robot vendors, right? So there's a lack of communication and integration between the different vendors, the devices, the systems, the entire infrastructure, and all that, right? So there's the infrastructure constraints, which is like they also have to interact with this infrastructure. There's also the problem of dynamic environments. So robots will have to deal with the people walking around and direct contact with like high levels of people that are not trained to walk around robots, right? Like especially kids. That's usually a big problem. There's also a problem of lack of realistic test environments. So simulation will play a very big part on this. So it's very expensive to if you have a big environment that you want to deploy robots, then you'll have to you can't recreate that and have a testing environment of that size, right? And there's also, of course, some cybersecurity concerns in many different ways, like increased reliance on the network for data transmission and many other security concerns that can arise out of this. So what can RMF can do, right? Let's see what we can do with this piece of software. So RMF can do task planning and allocation. So basically, we have a panel where you can say, I want to submit a task, and then you do it, and then RMF will allocate certain robot to fulfill your task, right? And it will do it in an optimal way. We'll try to do it in the most optimal way that it's actually possible. And here in the animated image, you can see how it's submitting a task. We have the simulation on top of an airport simulation, and we have a map with waypoints and the robot walking around, right? Then also after this, RMF will be able to manage the traffic. So there will be conflicts that will happen due to many reasons, robots moving around, people walking around. So the robots need to adapt, and RMF will have to solve these conflicts in an optimal way, of course. We provide door and lift integration. So robots will be able to actually share lifts, share doors, like we'll be able to open doors, use doors, and all that within infrastructure. And they're also able to interact with work cells. So work cells are basically, they will be consumers or producers of certain objects that will the robots will be using. Like in this example, there's this robot that is a workshop that is basically just providing some Milo cans to the robot for certain deliveries. So how does this work? So RMF is basically a collection of libraries and tools that will facilitate this interoperability between different robot fleets and the building infrastructure, and also automation systems like these dispensers or collectors that I was talking about, right? And as I said, everything is done in the most intelligent way that can be done. If you look at the diagram on the right, there's a core system where there's a dispatcher planner that it takes the task of dispatching the tasks, and we have the traffic monitor that will monitor traffic for conflicts, and then we have a scheduler, and then all around that we have the adapters that will interact with infrastructure. We interact with like different work cells. We interact with like different devices. We also have user interfaces for the users to request tasks, and the fleet managers for robots to be able to interact with RMF. Things that we do that we get with RMF. So we get simplification and standardizing of messages for this environments. So you can see there's application layers for work cell adapters, lift adapters, doors, and mobile fleet drivers. Now, one of the big problems that came with trying to integrate different vendors is that you don't have the same access to all the robots, right? So not all the robots are, sadly, not all the robots are open source, and you go to a facility, and that facility might have a fleet of robots that are not open, and the vendor is not willing to open that much. So there's certain levels of openness in this fleets, and with that openness, it comes a throughput potential that it's tied to that openness, right? So there's the no fleet API, which is basically the one at the bottom here, and that one will basically not allow us to do anything with it. So for example, with that one, there's not much we can do, right? So we basically just treat them as moving opticals, and of course this having a fleet like this in your infrastructure, we can't guarantee with RMF that you will not end up in a deadlock in your system. Read-only fleets will also be. It's another option. Is the option where we can read the robot's location, but we're not allowed to give any command to that robot. And if I'm not wrong, I believe with one of this, we can guarantee no deadlocks, but more than one will actually could create problems. We can't guarantee that it won't create problems, having more than one of this type of fleets in your infrastructure. Then we have the traffic light version, which basically allows us to pause and resume the robot. And finally, we have the one that allows us full control of the robot, and then we can just select the waypoints and control the robot. So this is the most desirable one if you want to get the maximum output out of RMF. Yeah, so what RMF does is that it will abstract the tasks for an improved flexibility. And basically, from the user perspectives, there's a web panel selects the task, and this will get to the dispatcher, and the robot will do it, right? But under the hood, there's a bunch of stuff that is happening. And there's first the smart fleet adapters will actually beat for the task, and then there's one of them will be selected. Schedule validator will validate that it's correct, and there's also a unified schedule for all robots. And this unified schedule for all robots and the infrastructure will actually validate new tasks that are coming that they don't have any conflicts, and they will also validate and monitor traffic as it goes around, and in case of conflicts, it will actually act as a mediator for the conflict resolution. And we'll see later on how I won't stop too much, because I think might not be of too much interest, but at least a high overview of how a conflict is resolved within RMF. So RMF also introduces traffic conventions. Fleets follow a common traffic lane layout. So now we minimize the fleet interactions, simplify adding new robots to traffic flow. Fleets will follow traffic management commands, and fleets will share mechanical infrastructure. Access to elevators and doors is provided by the high-level controllers that we have. All right. There's also emergencies implementations for fleets, code blue, fire alarms, and typically the get out of the way and stop moving kind of thing. All right. As I said, RMF predicts and resolves conflicts. So predicted plan from a robot might change because most of the human environments are variables and dynamic. So there's human traffic, there's unknown obstacles, there's lifts that might be open, closed, busy, not busy. There's a change on intentions. Some tasks might be canceled. There might be alarms happening and all that. So that's why RMF continuously keeps monitoring changes in the unified schedule, and will appropriately report that to the smart fleet adapters to go into a resolution to solve this problem. So how does this problem get solved, right? So we have, in this case, in this example that I'm going to use to illustrate how more or less how the traffic negotiation happens. There's a few assumptions that are done here. So basically is that each fleet does not know what the other is capable of. Each fleet can communicate a plan that is feasible for itself, and each fleet can see the other's plans and attend to plan around it. So that is the key assumptions that we need. So we have these three smart fleets that the robots came into a conflict, and now we have to solve and figure out how they're gonna work around it. So each fleet will propose their ideal itinerary that they would like to follow at this point. Then after that, each fleet will create their best attempt to accommodate the other's each one of the others robots proposal, right? So if we got smart fleet adapter A, then we got A's proposal, and then what happens is that B will create an attempt to accommodate A, and C will create an attempt to accommodate A also. So we get each one of them will try to accommodate the other two, right? And then after this step, then each one of them will try to create their best attempt to accommodate the other two, right? And this, of course, if there's more fleet adapters than involved in the conflict, it will keep growing. But basically, in this case, we have 3. So now we have C best attempt to accommodate A and B, and then also C will propose a best attempt to accommodate B and A, and so on, right? So we end up with a combination of the others proposed itinerary with an itinerary that is feasible for that fleet adapter, right? So we got an itinerary that is feasible for smart adapter A, but it's also accommodating B and C and accommodating C and B, and so on. So with this, there's a scoring happening, and there's each one of the solutions will get a score, and basically based on this score, the best proposal will be chosen, right? So currently in this example, the best penalty, there's a penalty, and the lowest is chosen. So there's many heuristics that can be used for this, and actually we have been trying different ones, and we will leave it also to the system integration decision, because different integrations will probably require different heuristics on this point. So for example, you can have you can have this heuristic being the sum of all the delays in completing all the tasks, but you might also add weighted on the importance of the task, right? So you might have some importance value that you assign to each of the tasks, and you want to add a little bit of weight to that important task, and you want to have that be reflected into this negotiation, right? So you want to select the ones that make the important task faster, and you don't care of the unimportant tasks. So this is still like we're creating different heuristics for different scenarios, and as I said, finally probably we will have several heuristics that you can use as a system integrator if you're using RMF. All right, so let's have a look at the toolbox that RMF provides. So there's a bunch of tools that it comes with RMF. The traffic editor is one of the most important ones, and is the one that will allow you to annotate floor plans. You can add walls, doors, lifts. So basically, you can create the map that you can use with RMF. It allows you to place simulation models. If you're gonna export this into simulation, you can create static models, and you can also add dynamic models like humans. So that's very cool. And then you can import and export these traffic lanes into vendor-specific fleet adapters to be used by the fleet adapters. Then we have a tool that is called Building Map Tools, which will take an annotated map from the traffic editor, and we'll convert that into a physics-based simulation world that you can use with Gazebo or Ignition. So this is an example of the office demo that has been converted from the traffic editor annotated map. All right, so yeah, that's one of the key things that I want to emphasize, especially for those of you that are not very familiar with robotics, is that simulation is super duper important. So in robotics, I'll say there's a big chance, like 80% of robotics happens in simulation first, because first hardware is expensive. Hardware it's a pain, so you want to make sure that when you get to the hardware part, your software is fine-tuned and doesn't have too many bugs, because otherwise you only want to focus on the hardware part, on the hardware issues that you have, and you want to have your software very, very fine-tuned, right? So simulation saves a lot of time. As I said, it allows you to fine-tune algorithms, and you can test with like you can have testing running at any point, at any time. You can scale, you can debug different edge cases. You can move it around. So it allows you to have this flexibility that you won't never have on a real world. And especially with these big X scenarios, simulation plays a really big part, right? So in our case, we use ROS and we use Gazebo and Ignition, and we can just in a matter of like a few days just switch directly, and we've done it a couple of times already. Switch RMF directly from our testing and simulation into the real world scenario, and everything works out of the box. Another thing that is very nice that came with RMF is that we created a lot of open source simulation assets, and we made them available for everyone. So you can find all these assets that we have that are related to deployments of robots in different infrastructures, and they're all open source, and they're available on the Ignition Robotics Fuel, which is the Ignition Robotics tool for cloud storing of these 3D models, and that allows you to automatically download these 3D models and use them in your own simulations. And then also, of course, the RMF core, which is the brain of RMF. So that is the part that we saw on the architecture before, that is in red. It's basically a bunch of libraries and utilities that assist vendors to integrate with RMF. So you can find pure C++ libraries for trajectory interpolation, path planning, schedule database management, conflict detection and resolution. And then we also provide the ROS wrappers of these C++ libraries. So it's not that you 100% have to use RMF with ROS. It's a C++ library without ROS, and then you have the ROS wrappers in case you want to use it with ROS, right? But of course, we provide all the tools and everything that you need to run it with ROS. So it might be easier if you just do it like that. But you're also free to do it however you want. And there's also a bunch of templates and examples of like smart fleet adapters for fleets without levels of control, lift door adapters, and abstract task configurations. Then we also have our operation dashboard, which is basically, it's actually changing quite a lot, but it's basically our web dashboard interface where you can submit your tasks, you can schedule, you can see the trajectory, you can interact with the system. As I said, we have different types. It's evolving because we're in continuous development. But I'll show you the version that you can play around with, that it's available on the RMF demos. Oh, here we go. So let me try to show you a bit of a demo of RMF. So I guess I'll stop sharing this part. Where is my stop sharing? Oh, yeah, new share. I'll share the entire screen now. All right, so you guys should be able to see my entire screen. Is that correct? All right, let me make this a bit bigger. So basically what I've done here, I'll go through, there's an RMF, there's an RMF repos with all the information and all the information you need. So what I did here is that I created my ROS workspace, and I have these RMF repos with the repos. This is all the repos that you have in RMF. So basically, if you follow the, let me check. What is going on? Wait, I can't see. Okay, so if you see the repos, then you'll be able to follow all the instructions. They're pretty straightforward, and you can basically just download the repos, compile them, and you will be able to run the demos pretty much out of the box. So for running the demos on ROS, I just have to do ROS2 launch, and I should have it compiled already. And now RMF demos, which is the package that contains the demo. And then I'll run let me see what demos we have. So I'll run the easiest, the smallest one, which is the Office, because I'm running on my laptop, and I don't know if, I don't know how much I can run here. So let's see. All right, so this is to be running. Okay, a bunch of stuff is start. Okay.
Marco, sorry, this is Gary, right? I have just one quick question.
Yep.
I ask.
Yep.
Are you able to currently run this on GPU?
What do you mean? What part of GPU? I mean, there's many parts of the. I mean, Gazebo uses the 3D of the GPU, but
okay. It's just
if you mean like the traffic. Yeah.
Okay, thank you.
So wait, let me see. Let me just run this. So now I need to go to host. So the web panel will be, the RMF panel will be on the
There you are, mute. I can't hear you.
Yeah. Something happened.
No, can.
Yeah. Something happened to him.
I
When he was
think-
running, I think he cut him off.
Yeah, I think the Marco, the connection dropped.
Yeah. I think when he was running the demo.
Yeah, Gazebo does, at least in my experience, it takes out a lot of memory.
Oh, yeah. Especially 3D and all that. It's almost like a game, man.
Yeah, it is supposed to contain
Like a
its own
sandbox
physics.
game.
Yeah,
It's like a
supposed to contain its
3D
own
sandbox
physics
game.
engine.
We lost Marco. I can't unmute him. I think he's trying to get his system back up.
Okay, let's wait for him now.
Yeah, it's pretty interesting. I bet a lot of people didn't know there's such a team in Singapore doing very cool open source project. I mean, you know, but a lot of other people didn't know.
Sorry guys, the Gazebo sometimes freezes when sharing stuff. Yeah, it happens too often.
No
Let's see
worries.
if I can show it now. Oh wait, I need to share my screen, right?
Yeah.
Let me put this on the other screen. Share entire screen. All right, so I'm gonna go to localhost 5000. Right, so let me see what else I got. Wait, I got this one. Okay, so basically you can see the robots here. There's Arvis somewhere where you can see the map, but I don't know where it is now. But yeah, it's fine. You can see the robot. There's a robot here, tiny robot 1, tiny robot 2, and then you can submit requests here. You can say, I want to do a delivery. So in this example, we have Coke here. So you can select the delivery task, which is the Coke, or you can do a loop. So loop means like between two waypoints. So basically you will select one waypoint and another. And so in this case, you have a bunch of waypoints here to select. And then you can have the end location also selected here. And then you have here the robots that are available. So you can see tiny robot 1, tiny robot 2 are available. And then this is where you will see the robot task summaries whenever they're being executed or they're done. And then there's also the option to select and submit different tasks in batches. So you will submit a JSON here with a bunch of tasks, and they will be all executed in order. So let me just select, like, for example, from COA, which is here, and we interact with the door probably, and then I'll send it somewhere here, which is the hardware room of the office. Let's check hardware 2, and we'll do. Let me have this one having a bunch of loops, and I'll submit a request. Now you can see that the request has been submitted successfully, and there's a task that is pending, and now it's active executing. And tiny robot 1 started doing it. Is the one who won the bid, and it's gonna start going from one place to another. And now if I submit another task, I can I'll select, for example, let's get from supplies, which is a waypoint that is around here. I'll send it to tiny robot tiny robot 2 charger. So then if I click and submit request, submitted successfully, it appears here, and then it's pending for a while, and now tiny robot 2 is assigned to fulfill that task. And then if I keep submitting tasks, they will be basically added to the list.
Whoops.
Presentation.
Yeah, maybe.
Yeah, I'll talk a bit about the because this is about open source, so I'll talk a bit about the community, which is a very interesting part. Let me just make this one big. And let me find. All right. All right. So you guys should be able to see. And yeah, if you guys go to the RMF demos, you will see that there's a bunch of other demos that you can try. There's the office, there's the clinic, there's the airport, there's the there's a hotel. I think that's it. Yeah, and then they have different characteristics. They have lifts, they have doors, and different fleets of robots and all that. So yeah, regarding the community, the ROS community is pretty amazing. There's so many contributions. As a federated project, we get a lot of people that collaborates, and it's great. Everyone has different ideas, doing different things, and it's quite amazing. So I would like to invite everyone that is interested in robotics to actually check out the community and join us. There's a bunch of community events related to ROS. They happen worldwide. This is some of them. We organize the ROSCon, and there's some local ROSCons. So there's like one world ROSCon happening usually every year. because of pandemic issues, we had a ROS World that was held online last year. But this year, there's an intent to make it happen for real in New Orleans around November. So we'll see what that happens. And yeah, it's a lot of fun. There's a lot of interesting people, and yeah, so I would really recommend this event for everyone that is interested. And yeah, where to start?
Wait, Marco, there's a quick question. Can a new developer join? It's in the chat.
Let me check the chat. Got closed. Can new developer join? Yeah, sure, of course. Yeah, you're more than welcome. There's this is where I'm getting at. So there's a bunch of places where to start. I would say that if you're totally new, get familiarized with ROS maybe at the beginning, especially the basic tools, tutorials, and all that. You get ROS.org, where is the main website for ROS. You get index.ros.org, which is the website where all the packages are, most of the packages are indexed. You get answers.ros.org, which is a Q&A system, sort of Stack Overflow, but it's specific to ROS. And then the place where everyone hangs out, which is the discourse. So that is where everything happens, where like every time there's a ROS release, the t-shirts get announced. There's a ROSCon, it gets announced there. Everyone that is something cool talking about ROS, then they talk about it over there. Then there's Gazebo part. Then Gazebo also has their own website, Gazebo Sim Ignition Robotics, which is the new version of Gazebo. Then there's the answers.gazebosim.org, which is basically the analog to ROS Answers. And then you get the community.gazebosim, which is also a discourse where you can talk about simulation specific stuff, right? And then regarding OpenRMF, it's a new project, so we don't have all these fancy websites yet, but we do have for those of you that want to get involved in it and want to read a bit about it, we have a book online, which is the ROS2 multi-robot book, which is this link over here. And then you can access directly the RMF, OpenRMF org in GitHub. I think I have more. Yeah, so these are more links specifics to RMF. So there's an organization that is OpenRMF that contains all the repos that are related to RMF. There's the main repo is called RMF, and it will contain the instructions to install RMF and to get started with it. There's a contribution guideline. You get the ROS2 multi-robot book that explains everything in RMF, and we try to keep it up to date. There's also RMF demos, which is the one that you can play around with the demos that I just showed, and you can see a bunch of GIFs of the different demos if you go into that repo. There's the Free Fleet, which is also an important repo because it provides an open source fleet manager for those people that have a fleet of robots but don't have a fleet manager. They can just use this one, and it will easily integrate with RMF. And then finally, the traffic editor, which is the tool that, as I said, you can use to create your maps and annotate them, and then export them either to the fleet adapters or to the simulation environment. And yeah, thank you very much. That's the end of my presentations. I hope it was not too boring, and I'm happy to take more questions.
Very cool, Marco. Impressive.
Thank you.
I'll start off with one question first. Are you able to disclose the real world deployment of OpenRMF? Like at what stage you are in now?
So we do work we work with the hospital. So we work with Changi Hospital. The deployment of RMF in Changi Hospital is called ROMI-H. So they actually have a website that is publicly available. I think they even have a video of ROMIH at the Changi hospital. We have more projects going on, but we're not able to disclose those yet. So for now, we're working on more different types of deployments. But the main one, this is the hospital is the main one that we started, and the one that is more advanced at this point. I think in the ROMIH website, you can see a video of some examples. Yeah, I can drop the URL here. Some examples of how the integration happened.
Yeah, I think most people probably didn't realize that our hospital is quite advanced.
Yeah, so that's how the problem happened, right? So the hospital had different vendors, robots, and they realized that they actually need a way to integrate these different vendors, right? And that's when Open Robotics came in to provide a more open solution for the problem. There's a webinar. I think the webinar video should be accessible.
Anyone else have any questions for Marco?
I have a question. Hey, Marco, this is Chinmay.
Hi.
Just curious, how adaptable is something like RMF to different types of robotics? So I work a lot with water-based robotics, surface vehicles, underwater vehicles. So would something like this be applicable in those cases? Because a lot of the things talked about are very specific to, like the examples you're giving, like an airport scenario or hospital kind of stuff. Do you think some of these things can be easily transferred to other kinds of robotic scenarios?
So yeah, absolutely. Basically, as long as you, so I guess for if you're doing something related to water, I'm not sure with are the main problems that you might face there. But if you're talking about task management, as long as I guess that you would have to create your fleet manager layer, and then once you have that, then you can easily integrate with RMF.
Right. Okay. But it is structured in a way where you could swap out individual layers for custom variants for different problems, kind of stuff, right?
Yeah, absolutely. And as I said, like even RMF is open to, like, you could combine even like different types of robots that are doing different things. Like you could have an underwater robot that is also connected. I don't know. Maybe I'm talking stupid stuff, right? But maybe just have like some robot that is not underwater that connects to that robot in a certain task.
Yep.
And as long as you have the fleet managers that allow you to manage those robots on their own, then this is like what comes as a wrapper on top, right? So you just integrate with the fleet with the RMF traffic management, and then everything should work.
Cool. Yeah, I mean, actually, the scenario you give is very, very valid, and that's something that people do all the time, where you have something that's underwater that's running around, but as you know, it's communication to stuff underwater is complicated. So you very commonly have a robot that's on top that's communicating and giving instructions or relaying data or something underwater. It's a very, very common scenario, actually.
I see. That's interesting.
And I think the interesting thing for me is one of the problems that you talked about initially, which was multi-asset and multi-vendor asset management, because that's also a problem that's quite common, where you have various robots from different vendors and you want to have a synchronized system to be able to manage them in whatever way you can across different vendors. And I think those kind of solutions, although ROS is getting into the picture, so that would help, But you know, I think those kind of problems, if there are already solutions for, or at least some ideas for solutions, would be great.
Oh yeah. So yeah, one of the things that we want to work more in is actually tasks, like the coupling task and task abstraction. So you can have certain tasks that involve you can easily adapt your task to different robots interactions and all that. Yeah.
Cool. I will take a look at this. I don't know how much I can manage to make it work, but at least it's a good thing to consider.
Running the demo should be pretty easy for you. Yeah, I'm sure.
Yeah. But that's not the fun stuff. It's more fun when you get it to run on the real robots, right?
Yeah, that's true.
Thanks.
Yeah, welcome.
Any other questions for Marco? I realize it's.
I have one question.
Rahim.
Yeah. So, how does this? I'm only interested in a simulation, not really with like the real robot. But if I do a simulation, how does it scale? I assume that all these libraries are open core and even like MPI, taking advantage of like multi-core and even multi servers, or do you do some sort of scalability stress test or something like that?
Well, because we use ROS for this, you're able to run the different nodes on different on different machines. So that's one of the key things that you can use for different scalability. We haven't had that need yet, so we actually have been running our demos and even deployments. Most of them they run mostly entirely on one machine. So it's usually, of course, a powerful machine, but it's still running okay in one machine. We do have the core is high. The core of RMF is highly parallelized, and then also it's as I said, because we use ROS, every single part of the system is very decoupled, and it runs its own node, and you can run these nodes entirely on one PC. So the scalability is right there, but it mostly, as I said, it mostly came for free with ROS, which is one of the advantages, and that's why it's quite popular in the robotics community.
And in terms of, I'm not super familiar with ROS, so in terms of like connectivity, interconnectivity, and stuff like that, is there some layer of like a fault tolerance? Let's say someone wants to simulate a very large fleet, and then suddenly a couple of those robots, lose communication. Is there some, when you do a lot of the planning, etc., suddenly there's some cases where things are with not a full picture. So that's one case. And also when you mentioned about heuristics algorithms to kind of do this kind of finding bottlenecks or issues, does it come to sometime you have to prioritize specific tasks because actually the solution is difficult to reach, or like when I see your diagram with like trying to compromise like one task versus the others, etc. It's okay with like three let's say three machines or three robots, but when you have like 100 or more, the whole task become very much NP kind of thing, NP, like an NP problem in a sense.
I can take that question if you'd like, Marco.
Yeah, sure. Go ahead, Gray.
So, yeah, hey, I'm Gray. I'm from Open Robotics as well. I decided to kind of
maybe
hang out in here
yeah.
while doing
I'm also from Mesta IHPC, so that's the kind of family kind of thing.
Okay. Yeah. So let's see. So there were a few questions to unpack there. I think the first was fault tolerance. So the whole traffic scheduling and negotiation system is like designed down to its very core to assume that there's just bad information in the system or missing information, and that as time goes on, everything's going to change, and like all, you know, any prediction that was ever made could turn out to have been wrong. And so the whole system just tries its best to react to whatever the latest available information is. So we have this concept of a conflict, which is pretty similar to collision detection, but not exactly the same. Without getting too much into it, you can think of it as collision detection. And the idea is that all the robots at any given moment are reporting their own best estimate of where they are and the trajectory that they intend to follow in the future. And anytime we detect a, let's say, collision between these future trajectory predictions, we tell those robots to negotiate with each other using the scheme that Marco mentioned earlier about like each one saying, here's what I'd like to do, and then the other saying, okay, here's how I could accommodate that, and then picking the overall optimal one in the end. And so that whole system is constantly running and constantly updating based on just the latest, best available information for each individual robot, each one self-reporting. So we basically deal with fault tolerance by just saying, be ready to change your plans at any time. So if a robot goes offline and we can't hear from it, everyone else will just kind of stick to whatever their last, best schedule was. And then if that other robot pops in later and says, oh, hi, I'm actually in this other place that I didn't predict, then everyone will just adjust to accommodate that based on negotiating. So that's how we approach fault tolerance. I think there was a question about scalability as well. You could see the negotiation process, if you make it like go all the way to absolute completion, it is combinatorial. So the scaling is quite bad based on the number of robots. But one thing that is actually nice about it that we haven't really been able to, we haven't had time to explore this very much, but you can actually get a solution without working the negotiation out all the way to completion, right? Because any single thread of accommodations is a valid solution. So if you focus your resources on just completing one thread, then you actually have linear scaling in the number of robots negotiating. So if you have a lot of robots, then what you'll probably want to do is tell them to focus on a certain priority order of accommodations, and then you get a linear scaling. If you want the guaranteed optimal solution, then it is combinatorial. So for a small number of robots, you probably just want to bring it to completion to make sure you're getting the best answer. But for a lot of robots, you probably want to pick a single thread to work out. But that isn't a problem we've really worked on yet. But it is one that I'm eager to get into when time allows. Was there another question? I'm not remembering.
No, I think it's yeah, I think one has to try and read the code and experiment a bit to assess how useful it is for our own scenarios. Very interesting to see not only the different layers and the different parts, but also the graphical interface, the dashboard, everything as a big complete system. It's very, very interesting. Thank you very much.
It looks like ROS is actually quite a big, ambitious project. You can almost spend like one whole day just on ROS. Anyone else have any question? I realize it's maybe getting a little bit late for some. Marco, are you able to share the slides?
Yeah, sure.
Yes.
Just
if you have
how
a
do we
link,
do that?
or just send me the link later. Or if you have a link now, you can paste it on the chat, and I can then post it on the Meetup event page as well.
Okay.
There's actually a discussion section for every event. Yeah. Okay, if there's no question, are you guys like interested to do a quick rundown, like so everyone gets to at least to speak, or to know everyone? It's 13 people online. Hey, everybody already knows Marco, myself, Max, Gray is also with Open Robotics. Okay, don't be shy. Brahim, I think was there. Brahim, Chimay, Gary. Anthony. Okay, Anthony was our speaker last time. Who else is there? Elliot, want to say something? Anyone else want to introduce yourself? So again, free and open source Singapore, we don't focus on any one open source project or technology in particular. So feel free to come to us if you have you want to talk about anything open source. We try to do a meetup every month, normally on the Thursday. So as for myself, I'm currently working with a company called Valia.net. We do server hosting. So. Anyone else? No? Want to say anything? If not,
I think I'll go then. Yeah. Hi everybody. This is my first time here. Yeah. I think I'm in a. I joined a group that's like a lot more like in a bigger league than mine, because I'm not exactly a developer. I'm actually a technical artist, but I'm very interested in the open source world. Just like hacking stuff together, creating my own like solutions to my own problems, that kind of stuff. I mostly handle like the software side and on the computer graphics side. Like I do a lot of shaders in Blender, do a lot of rigging, do a lot of animation, stuff like that. But I do a lot of like my own programs and games on the side. Yeah, and I'm joining this group because I want to get to know more people who are interested in open source.
Yes. Are you able to maybe in future do a session on Blender? Because I think it's come a long way. Blender.
Yeah, it's definitely
I was actually looking for Blender because some years back there's actually a Blender user group, but I don't think they have been meeting.
Dang. I wish part of that group, yeah.
But the last few years I haven't seen them like holding any meetups or events. So yeah, actually because I've been watching all the latest videos on Blender, they're actually quite getting to be really, really good. Probably Anthony will be interested.
Cool. Yeah.
Blender.
I mostly specialize in animation rigging, but I'm a generalist, so I can do much stuff.
Cool.
Just let me know if you'd like to I guess learn anything. I'm more than happy to share. I'm really passionate about the computer graphics field. I really enjoy this field. So
very good. Great. Welcome. Elliot, I think you show your face.
Hi. Yeah, so I'm Elliot, and it's really nice to meet you all. I'm currently working as a software engineer, so it's actually my first job, but I've done a few internships before, one of which was actually at A-Star. So small world. And when I was there, I was working on a robotics platform based on ROS 1. So it's amazing to see how far the community has come since then. Yeah.
What kind of software do you do now?
So right now I'm working at GovTech, and I'm working on cloud infrastructure and some of the backend APIs. When I was at A-Star, and I also did an internship at ARM, I worked on a few software packages for ROS 1. So yeah, that's how I ended up here.
How about you, E? Are you comfortable to speak a bit? Thanks, Alan. I can help you unmute. Oops, I can't. Are you? Yeah, I can't I think he's muted on the end. I can't unmute him.
Sorry.
Oh yeah.
I guess unmute. Hi.
Yep.
Currently, I'm just a career changer. I'm interning with this Continental Automotive. So ROS, I have heard about ROS, but I never really go deep in. So today's quite an eye opener. So that's why I asked if it's okay for someone who is new to join.
Yeah. Most welcome. But what do you do now with this company?
I'm actually doing this software testing.
Oh, okay.
Yeah.
Cool. SQA, software QA. Okay. Cool.
That's all.
Yeah, I managed to go almost everyone now. Okay, cool. I don't want to take up too much of everyone's time. So shall we call it a night? Yeah. Okay, so we actually, I recorded this session, so I don't know if everyone's okay, but we're gonna put it up on YouTube. So we do have a YouTube channel. If you happen to find, there are some past videos of our meetup as well. So thank you everyone for coming to join us. Hope to see you all maybe next month. Okay, and feel free to come to us if you want to share your open source experience and knowledge. All right. Thank you, Marco.
Right.
Thank you,
Thanks,
Gary.
guys.
Thank you, everyone.
Thank you.
See you
Thank you
next
very much.
month. Bye-bye. Have a good night.
Thank you, everybody.